Okay. Hello, everyone. Welcome to the session 87 from the Fluent Bit office hours. And today we're going to do a quick recap of what happened at KubeCon last week. And plus also going to do a kind of a quick intro about the project, what was done, what was the outcome, what others as AI companies are doing with Fluent Bit, which is really interesting. So you might get a lot of content here. I'm going to start sharing my screen. There we go. Awesome. So as a recap, last week, we released Fluent Bit version 4.2, which is considered a major release. Okay. And thanks to this, well, before we get started, I want to say thanks to our sponsor, Chronosphere, who's helping to like a lot of developers from the project and marketing activities and everything around. So thanks for that. And Fluent Bit exists pretty much because we want to solve the problem around data volume. So every year we're getting more data from applications, and when you want to inspect the data, it becomes a trouble. So year over year. And actually, if you abstract from that, you are a user who sits here on the right trying to gather this data analysis. But in reality, what you face is a lot of complexity around data where it comes from different sources, different formats, and do data analysis gets really complex. And if we think about microservices where your application are being distributed now, and maybe your application has many replicas because you're scaling up, doing this data analysis gets really complex, even more around performance, right? Because every user would like to get more performance at no cost. But if your volume is going up, how do you make sure that you get your insights at the right time or get the right data to do the analysis, right? Because having a lot of data does not mean and does not correlate with a lot of value, actually can correlate with a lot of noise. So, and you need the proper tooling that helps to move this data, but also apply some business logic on top of it that allows you to filter out things that you don't need to process or analyze. So when the data come from different sources like syslog or systemd or any machines, and you want to send it to a place for data analysis, you need the right tool for that. And that is Fluent Bit. Fluent Bit is a vendor-neutral solution that has been around for 10 years that connects many type of source of data that could be local or over the network, like HTTP endpoints, can receive data from OpenTelemetry, it can send data to Splunk, to Kafka, and allows you to do this integration, right? Data collection, processing, and what we call its delivery. And Fluent Bit is driven by a lot of key principles, right? I always say this, that we always try to have a project that is really high performance, that consumes a lot of low resource usage, is fully vendor neutral. And with vendor neutral, is not just about to be in the CNCF in a vendor neutral foundation, but also a project that is able to integrate with competitors, but is able to integrate with also with other ecosystems, right? And from ecosystem perspective, Fluent Bit is a very small core that has a pluggable architecture, and that's how we are able to connect different sources with different destinations. Fluent Bit is a graduated project together with FluentD, both at the same level. And there's some news around where what is used to be called the FluentD organization is being renamed by CNCF to the Fluent organization. So both are under the same umbrella. And today, well, last week we were celebrating, well, this year actually, celebrating 10 years of the project, more than 15 billion downloads. Actually, we stopped content. I think that was the latest count, and has been adopted widely by all the cloud providers and companies in the AI space today. So for those who are Fluent Bit users or indirect users of the project, so what's new in Fluent Bit 4.2? First of all, we started supporting a specific format from our syslog, which is very old, but we didn't support it. But now the enterprise is asking for this, which is the RFC protocol version 6587. So if you receive data from firewalls in syslog format or any type of archive application, yeah, now you can do it with Fluent Bit without any major problem. Now we have extended also the certificate supports for TLS, meaning like if you have your own custom certificate, actually in Windows, now you can connect to this registry and get those certificates to communicate. This is very well known and used in the enterprise. in a very specific security context areas. Now, in Fluent Bit, before for the two, we used to have this, what we call attack-based matching rules for routing. So if you want to route data from a source to a destination, you used to map different tags and match rules. Let me use this application to show you how this works. Katie, can you confirm that you can see this screen and not just the slideshows? The slides.
Yes,
Okay,
I can see the screen.
Okay, awesome. So when you're doing tag-based matching routing, it's like you have an input, you define what we call a tag. A tag can be like a label. And then in the output or the destination, you create what we call a matching rule. This, for example, says that everything that starts with app.whatever will be routed to Splunk. This one will receive everything that starts with nginx.whatever, and OpenTelemetry output will receive everything. So if we simulate the routing, how it happens is like the source attach a this kind of tag, right? And Fluent Bit the router will send information to the right destinations. Now, if you focus in the second source here, where the data is tagged with nginx.access, the data will flow differently, right? Because Splunk is just waiting for messages that has app.whatever, while this OpenSearch, is waiting for a different pattern. Okay, so this is how traditionally tag-based routing works, and it has been there. It works, but however, now in the era where OpenTelemetry and other protocols are emerging, now we just don't have a context that as a tag, right? That belongs to a single record. Now we can have a metadata that is associated with a bunch of log records or metrics or traces. And now you would like to do routing decisions based on the metadata and not just on the tag that was associated by the input plugin. And how this general works. Let me show you, let me just jump to this slide to show you the context that was an interest. So in the next generation of routing engine in Fluent Bit, which we launched with Fluent Bit 4.2, now we introduce direct routing. Direct routing means that an input plugin that generates or receives data and for that data gets ingested into the pipeline. The direct routing means I'm not going to route based on the tag, but I'm going to route this information based on the content, either from the metadata of this data or from the same record. And you can do conditional. So you can create a conditional. For example, if the metadata for all this bunch of records contains a pattern, the data will flow to one place. If it belongs to a different pattern, it will go to a different place. So we will have conditionals. This is an extension to the routing mechanism, but it does not add any breaking change to what we have today. Okay, so let me show you here. So we have the direct routing, conditional routing. I'm going to use two web apps to demonstrate how this works from a visual perspective. Okay, these are not UI management tools, but for example, imagine that here on the left you have one record, right? A single record, and this is the record, right? You have a message, a type, and so on. And if we play this, if we send this record through the pipeline, the conditional router will say, if we have certain configuration, will say, okay, if the type is error, it will go to OpenSearch. And actually, that's what it does. Okay, so it takes data, it looks up for a field, and based on that field, it's going to route the data. Okay, if I have another record with a different metric name, with different type, and I play this, and we say, oh, if the type is metrics, the data will flow to OpenTelemetry, and so on. So you can now construct different type of configurations based on the content of the record. So you get conditional routing with direct routing access. And if we have another example with type of logs, so type of logs will flow to a default storage, which in this case we set up as Amazon. So everything that did not match any condition will route to a certain place. That's the whole context when it's applied to a single record. Now, if we have something that we call metadata aware, where a bunch of log records has some metadata, right? Imagine that this is a metadata. Okay, service, we have a key. This is kind of OTLP style, right? It doesn't need to be like that. And then here we have the record. The UI does not allow to scroll down. We have a bug here, but for the purpose of the example, this will work. Metadata, okay. Oops, oh, let me check here. Okay, this is the first example. So if the log records, take a look at this, the conditional that we have here. If we have hotel resource attributes where service that name equals payment service and the log body has something like log level equals error, the data will be routed to OpenSearch. So now you can see that you can start constructing very complex routing conditions for the data, right? And so on. So if you have other records which have a different type of configuration, we'll route to the different place. Now, how this looks like in practice from a configuration perspective. First of all, this is 4.2, so all this new routing experience exists in YAML. Now I have here another web app to show you how this works. Okay. And how this works. Okay, here we have the Fluent Bit configuration. This is the pipeline. Basically, we have the inputs. So you might be familiar with it. So inputs here, we have the HTTP, which is a receiver over HTTP. And then we have, this is new component, the routes component, routes. So the routes section attaches to the input and it's run after the processor. So if you're using processors, you're familiar with it, yeah, this runs like the input ingests the data, it gets processed if you have processors, and then you define the routes. So the routes are defined inside the input plugin. And we have the routes is applied per signal type. So for logs, for example, for all logs, we're going to define one matching rule, right? That we will have a name that we can visualize here. So this route will be called payment route. This name is just for us to understand what we have in the configuration or for the logs. And then we have the conditions, and the condition has rules, and the rule says, if the context in the body of the log record has a field called service, which value is equal to payment service, it's going to be routed to route 1. Okay? Now, we can have a second conditional that says this will be called checkout route. Okay, and checkout route says if the context body and the service equals checkout service, the data will be routed to route 2. Okay, and this is quite flexible because also you can send the data to multiple places, not just one. Okay, and if all the data did not match anything from the above, the data will be sent to the destination that is called route default. Now, you will notice that here we don't have the tag matching context. And you will notice that in the outputs, we just did this for simplification and configuration. This is just for testing. Actually, we can remove this. It should not be an issue. So we have standard output, which we call route 1. So when you set the alias, you can use the plugin name or the alias that was set as that this one will match, for example, route 2, this one will route the output of the condition number 2, which is this one on line 19. So you can have many outputs and you can link the data as whatever you want. For example, if you want to do a modification here, and for the route number 1, that is called payment route, and we're going to say, oh, this will flow to route 1, but also will flow to, oops, to route 2. And you will see that data will flow to both places. Okay, this is a visual example of what will happen when you change the configuration. So this is one of the biggest change in how we are building the next blocks on Fluent Bit on how to become a better telemetry router in general. And yeah, so we're quite excited about that future because it has been asking for a long time. And with our new OpenTelemetry users are saying, we're using the OpenTelemetry collector. It has these routing capabilities. The experience is not well useful because it's kind of disconnected from how it's composed in the configuration. And we're working with the community to get this together, how to having inputs, defining routes associated with conditionals. So this is kind of the new foundations of how things will evolve in the future. And again, this is only available in YAML. Okay, let's go back to our slides. So, and some takeaways from KubeCon from last week. I think that one of the biggest one is was the surprising keynote from OpenAI. Actually, one of the things is OpenAI, I'm going to give you the spoiler here, is using Fluent Bit on every single node of the cluster. And for them, reducing the CPU usage of any type of system level application help them to free room and make more space for other tools that they run. So I'm going to just guess, right? They're running ChatGPT services in the backend. This generate a ton of logs, but of course they're really intensive computing. They're writing a lot of logs, a lot of information, and that takes a lot of resources. But if your log agent is taking so much CPU, and any type of log agent, you would like to optimize that. So since they are using Fluent Bit at scale, they were looking for ways to even reduce even more the CPU usage so they can free more. And they found, hey, there's something wrong here. They applied a perf. Well, you can watch the keynote. It's like a 5-7 minutes keynote, which is really good. We have the QR code and the link in the slide. They were showing how this, with a little configuration change, because we suspect that we have maybe a bug or a bug in how we process tail. Well, a bug could be unexpected behavior, right? However, it works fine. The tail plugin works fine. But when we have to incur many system calls to achieve the right behavior, because there are many corner cases around log rotation, truncation, when the kernel flash the data to disk and we don't trap those events, there are many things. So we abuse from the fstat system call for that. And what they found is hey, what about if we try a change in the code to reduce the number of system calls? And they found that, hey, with a little change in the configuration by switching the backend from iNotify to stat on that specific use case that they have, they reduced the CPU usage by 50%. So that means that they were able to free 30,000 CPU cores for the AI workloads, which is insane. So I invite everybody in the community to watch this presentation from OpenAI. So I think that the main takeaways is okay, so things can be run even better. We can optimize a lot. And well, today actually our Fluent Bit team maintainers were going to meet with the OpenAI team to try to discuss how we can get some improvements on this area. There's always certain companies when you run a project that push your boundaries. And I would say that the latest 3-4 years has been financial institutions like banks who run this in financial system. But I think that the AI workload systems are even pushing us to the next level. So we're really happy also to work with the community from AI companies to provide a better solution for them that actually will benefit everybody. Okay, so if you're a Fluent Bit user, you know that you might see in photos in presentations that people used to wear some weird, or not weird, but fancy Fluent Bit t-shirts. So for every KubeCon, we do a new release of Fluent Bit, and every release comes with a signature t-shirt. So this is a t-shirt for Fluent Bit 4.2. And this version is, this design is really cool. And if you're going to be around AWS reInvent on December 1st to 4th, please stop by the Open Search booth where we will have our Fluent Bit t-shirts. So Katie, who's in the call, will be there. So we welcome everybody to just go ahead and say, hey, I'm a Fluent Bit user. I want to get my Fluent Bit t-shirt. And nonetheless, as I said, please take a look at these QR codes and get involved in the project. You can do it through GitHub. We have these Fluent Fridays. We have the newsletter, and we're always having these new workshops who are sponsored by Chronosphere. And if you want to join us, hey, we are always hanging out on Slack and have different channels. So if you have questions, let us know. Otherwise, we will be happy to follow up the conversation on Slack. Katie, I don't know if you have questions right now.
Yeah. I don't know, John, Gaurav, if either one of you attended KubeCon last week, if you have any kind of questions that you had or any questions that you had over anything that Eduardo talked about or anything that you took away at this time.
Nothing from my end.
Great.
Same.
Great. Well, we appreciate you both joining us. As Eduardo noted, if you have any questions, you can find us on Slack, and thanks for joining today.
Thanks, everybody.